Hello everyone. In today's session we are going to learn about indices, and today we are going to focus on the basics of indices, and if possible we will look at the laws of indices also. So let us proceed. We all know that we can write 3 multiplied to 3 can be written as 9, or we also know that 2 multiplied to itself 3 times can be written as 8. Now both these results can also be written as 3 with 2 as its exponent like this, and 2 multiplied to itself 3 times can also be written like this. These are called exponential form. These two are called exponential form. Here 3 is called the base of the exponent and 2 is called the exponent, also known as index, and so also known as power. Especially we can call this as 3 square, and we can call this one as 2 cube. So if I have to write the basic, I can write a to the power m is equals to b, where a is your base and m is your exponent or the index. Here we must keep in mind that a and b both are rational numbers and m is an integer. But we know that the integers can be negative also. So if I have to write a to the power minus of m, then what does it mean? A to the power minus of m is reciprocal of a to the power m. Now this m can also be fraction at times. That is, I can also write a to the power 1 by m. When the exponent is fraction, then it is called fractional indices. Fractional indices, also known as surds. Now let us look at some of the laws of exponents. Suppose a and b are positive real numbers and m and n are rational numbers, then the following rules hold. First rule, if you have a to the power of m multiplied to a to the power n, in this case the base is same but the exponents are different, then we can obtain the same result by taking a to the power m plus n. Remember, if there is a product with same base but different exponents, then we can add the exponent. Second rule, if you have a to the power m again to the power n, then we can obtain the same result by taking a to the power m into n. That means by multiplying the two exponents. Third result, if you have a to the power m divided by a to the power n. So here again the base is same, the exponents are different. Instead of product you have division or quotient. So in this case, we can obtain the same result by subtracting the exponents. Fourth result. You have a to the power m into b to the power m. Now what is the difference between number 1 and number 4? Here the base are different but the powers are same. So we can simply multiply the base together and write the same power. Similarly, if you have a situation where a by b is to the power m. Here again, the base is different, but they have the same power m. Then we can open the bracket and assign the same exponent to both the numerator and the denominator. Let's look at number 6. If you have a to the power minus n, then it can be written as the reciprocal of a to the power n. Further, it can be translated into 1 whole divided by a to the power n. Remember, 1 to the power anything is 1. So we write it like this. Next result. If you have a to the power n is equals to b to the power n such that n is not equals to 0, then a has to be equals to b. Similarly, number 8, if you have a to the power m is equals to a to the power n. What is the difference? In number 7, the base were different but the powers were same. That's possible only if the bases are equal or same. In this case, the bases are same but the powers appears to be different. This is possible only if m is equals to n, provided that a is not equals to 1. Provided that a is not equals to 1. Why? Because 1 to the power anything will give you the same result. So even if m and n were not same, if a was equals to 1, it will give you the same result. The last one and most important, anything to the power 0 is always 1. So these are the rules of exponents or indices of real numbers. We shall learn more about it in the next session.